set of all coplanar points such that the difference of the distances between two fixed points is constant. So, thought I had this up. Hold on 1 second. We're going to look at this. Do you see it? Do you see it? Hyperbola? Nope, that's parabola. I know I've got it on my website though. Okay, so we're going to trace out the hyperbola using the difference in the distances. Oh, come on, guys. Animation is not appearing. Come on.
Where is MSCD?
Yeah, but it's called a flat sword.
Well, come on.
Find it right on.
Doesn't that look good? Y'all like that?
I see it.
I don't see it.
Hey, it worked last period.
Bam. Perfect. I should get a haircut like that soon.
Try a different browser.
Oh, that's a good idea. Hey.
Oh, I got a detention last period for opening the door, so I can do that again.
Yeah.
What?
Did you really?
What? That's not right.
Was it? Don't open the door. I was like, what? He's knocking. Okay.
Oh.
Your favorite word? Mario. So pretty.
I thought the sample was the nicest one. I'll show you.
Okay, well, we'll give this website some time because it's not happy now. It worked just fine last period. And we'll come back to it later and maybe it'll work. Okay. So, it's the set of all coplanar points that the difference between the distances remains constant. And that website has a really cool animation when it works that shows you that. Now, what do we notice that's the difference in this formula from the ellipse? Good. So there's still, both variables are squared. If only one is squared, then it can only be a parabola in this conic unit. So both variables are squared, and it's a difference. So whether we have the same coefficient or different coefficients, if it's a difference, it is a hyperbola. All right, so our center is going to be the same, HK. Now, if the x is positive, it's going to open horizontally. And if the y is positive, it's going to open vertically. Do y'all see the difference? X positive horizontally, y positive vertically. Now, the transverse axis is the one along the way it's opened. So from here to here would be the distance of our transverse axis. And when it opens this way, this is A and this is A from our center. So the length of the transverse axis would be 2A. Now the conjugate axis, which is what we need, it helps us draw it properly, is going to be 2B. Now the foci. To get the foci, instead of doing the a squared minus the b squared, we're going to do a squared plus the b squared. So when it opens horizontally, we'll add and subtract that to our x. So it's h plus or minus c, k. Our vertices, we're going to add and subtract it to our x also, so h plus or minus a, k. And asymptotes. On the hyperbola, what we have are asymptotes, which help guide us in drawing our hyperbola. And I did a terrible job. But we have two here, and they just kind of follow along, something like that. And we have another one coming this way. And do you see how the hyperbola just kind of rides along the lines? Okay. So those are, and we're going to leave this in point slope form. I don't have enough room right here, so I'm going to write it down here. So it's going to be y minus k equals plus or minus b over a. That gives us our slope of that line, and x minus h.
It's a very short line.
So if it opens vertically, it's just going to change a little bit here. Our transverse axis is going to be 2b, and our conjugate axis will be 2a. This time we're going to add and subtract to our y value to get our foci, and we're going to add and subtract to our y value to get our vertices. And then our asymptote is still the same.
So it's basically the same principle for all of them.
Yes, it is.
Really nice.
It is nice.
Plus or minus?
Here?
No, the second one. Is it plus or minus?
Oh, it should be plus or minus. Thank you. It's not just minus. Thank you. Okay, so let's do a couple examples. I'm going to do the first one, and then I'm going to have you try the second one. They're quite similar. How do I know that example number 1 is a hyperbola?
Because it's a negative.
Because the minus, the negative, and they're both squared. Okay? So, let's go through and get our stuff. Where is the center?
2, 0.
0. Okay, I'm going to let you guys catch up.
Are we finding everything? Are we finding everything?
We are going to find everything on this one. So we have the center at 2, 0. Horizontally, what distance would I move?
6.
Okay, the axis is 6 units long, but we're going to move 3 in either direction because the square root of 9 is 3. So our vertices, because the x is positive, these are our vertices, we're adding and subtracting 3 to our x value. So it's negative 1, 0 and positive 5, 0. So that's our transverse axis. It has a length of 6. Now our conjugate axis would be 2. Now if this were plus instead of minus, we would just circle this up and basically form an ellipse. But this is a hyperbola. So we don't do that. One way that we could sketch this in at this point is to draw in, and this would, it's not actually part of the graph, but it might help you to draw it correctly. I'm not going to make you do this though, because you might be able to visualize this box in your head. All this box does is it helps us to correctly form our asymptote lines. The asymptote lines go through the corners of this little imaginary box. Okay, so because the x is positive, this one's going to open up this way, and it kind of follows along our asymptote lines.
So nice.
Yeah. So that would be on the insides here on either side. So our foci, we're going to add and subtract to our x value from the center. So it's going to be 2 plus or minus something, 0. Now for the hyperbola, c squared is the sum of these two. So 9 plus 4 is 13. So I take the root of that. So it's 2 plus or minus the square root of 13. That gives us our foci.
Our foci are located in the transverse, right?
Yes, they're on the transverse axis.
In the Yeah, okay. Never mind. Makes sense.
And
Basically, they just switch these. So like you're yeah.
okay, and then our asymptotes were those equations y minus my y value at the center, which is 0, so I don't really need that, equals negative b over a, so it's plus or minus, not negative, plus or minus b over a, 2/3 x minus my x value at the center. So does this have a positive slope of 2/3 and it's been shifted over 2? Yes. Does this have a negative slope of 2/3 and it's been shifted right 2? Yes. So do you see how this equation is the equation for those two lines?
Yes.
And that's it. Okay, you try
That's close.
example 2.
Okay. Check yourself 3 right.
See you. Remember those sticky note graphs Miss McKell had? They were so convenient.
Are those cool? Brian has them now.
Wonder where she got them.
I'm sure she ordered them from some educational website.
She needs to have sticking on her paper. So nice. Or you could be European and just do all your work on graph paper.
But you can.
I always did.
My mom did all her writing in like her English homework. They do everything. They didn't like use lines and notebook paper that much.
What if they use graphic for English?
They just write on it.
I used engineering paper for everything, but it's gridded, and it helped me keep everything
Well, I guess it's not
nice
really-
and
I guess
neat and
it's maybe engineering
organized.
Paper, I guess it's not. It's just like graph paper style. They have line paper too, but they mostly use graph paper for everything. Put a letter in each box. No.
Yep, I heard y'all say it. It is a little different because the Y is first, so be careful about that.
told you what career path he's choosing? He can do like math, like engineering, or teaching.
I imagine it will have something to do with math or physics or a combination.
I wish I was chosen math as a kind of natural.
I wish I liked it as much as he did.
Yeah. I think it's probably really hard for people to major in teaching now, since they're only really keeping older teachers. Like they don't really hire, like unless you have like a specialized thing.
They're trying to get the teachers with 30 years or more out of schools.
Oh, really?
Yeah.
But some of those are the best teachers.
Yeah. Because they actually know what they're doing. I mean, although it is aggravating when teachers like tenure and
Yeah.
which is why they.
Like my 8th grade math teacher should be fired. He didn't know what he was doing. He told stories about his life.
Man, what is it?
His idea of geometry was having us memorize.
My grandfather used to say.
Yeah, two of my teachers are new this year. My German teacher and my health teacher. They're both kind of like specialized fields. You can't like
Yeah.
teach them around it. So like if you teach like math or English, though, it's kind of hard to get a job now. Oh, proofs.
It's easier in math than it is in, say, English or history.
Yeah, I think
Those are hard.
lots of people do history teaching.
Especially if you have, like, if you qualify to teach gifted
Mm-hmm.
because the more specialized you get, the more you options you have.
Yes.
My mom said that when she like gets her 30 years, she wants to see so she can find a job teaching at her college to teach new teachers.
Very cool.
My husband was like, she applied for a job at her college. Now she's teaching student teachers how to teach.
Awesome.
Yeah.
All right, how'd you do?
Lovely.
Great. Okay, so this one's opening up and down. Do you see how I did the asymptotes without actually drawing in the box? If you can do it without actually drawing in the box, that's fine. If it helps you to draw the box, do that. Okay, any questions? Are we good with the foci?
Why is it opening up and down?
Because the Y is the positive one.
Okay.
Okay, how do I know example 3 is a hyperbola?
Subtracting.
It is. Squared subtraction. Okay, so I'm going to walk you through this one together. There is one thing that students tend to miss, and I will stress that, and then you guys won't miss it, and it'll be awesome.
Yay.
All right, so the first thing we do, obviously, is group our x's and y's and factor out the coefficient. So we're fine on whatever term comes first. But on the next term, we're factoring out a negative, and here is the one little spot people miss. When you factor out a negative, it changes the sign. So that's the one thing I want you to watch out for. When you factor out the negative, make sure you change the sign in the middle term. So here we're adding 1, but over here we'd add what?
Negative
4. Here we're adding 9, but over here we're adding negative 81.
And that negative just counts as the negative in that position, right?
Correct.
So, Olivia, did anyone get detention first period?
Every single it was the best looking homework I've ever seen.
That's awesome. Other than ours, right?
Wait, really?
Yep. I was thinking, well, maybe I should find a way to do this every day. But I really can't give detention for you not doing homework. But if I give you class time to work on something, and you don't do that, I can give you detention. So that was the only reason I
I request no class time.
had that option. Okay, so does that make sense? It's just like the ellipse, except you have to just be careful about factoring out a negative. And then when you get it in the right form, you can do all that other jazzy stuff with it.
This one would open left to right, right? This one would open left to right.
This one would, it certainly would. Yes. All right. Now, let's say I told you these were the vertices and the foci of a hyperbola. What's the equation? So let's think about what we have here. All right, we have vertice at 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So we know it's opening left and right, right?
I put it at 6.
I put it at 6.
I kind of like these problems. It makes sense.
Okay, now the foci are here. So we know the x squared is going to come first, and then the y squared will be subtracted from it. And we know the center is at 0, 0, because what's halfway in between negative 5, 0 and positive 5, 0? 0, 0. So I didn't have to do anything with that. Now, the distance from the center to the vertex is 5. So what goes under the x? 25. Now, we just have to figure out the y. Well, we know that c squared equals a squared plus b squared. And we know what c is. C is the distance from the center to the focus.
So 49.
So it's going to be 49 is equal to 25 plus what?
B squared.
B squared.
24 squared.
24. And we got it. All right, you have a worksheet for tonight on hyperbolas. You're just doing the circled problems.
You did a beautiful job on these notes. They're so easy to follow.
Yes, sir. Really? 4 minutes? Really?
So on circle.
That's mom's probably gonna be nice to say.
Ryan, did you get a really hard one?
I turned it in yesterday.
Oh, they're very
Honestly,
easy
mine,
problems.
I am very proud of my 34 copies.
Miss Willoughby.
A lot of printing.